Hello students, this is our lecture number 2 and today we are going to discuss about the variables, data types and type promotion examples. So let me give you an example of what is a variable. By this time we have studied C, we have studied C++, okay. So you should be knowing what is a variable, but still as just a kind of a recap, suppose there is a memory location. Okay. Suppose there is a huge memory location of the computer system and the memories of the computer systems look similar to this, not exactly. Logically speaking, it looks similar to this. It has a series of cells where each cell stores the information in the form of bits, that is zeros and ones. So for example, this is a memory of the computer with the information I store. Suppose I want to store some information in this highlighted memory in the form of the binary. Then before I store any information in this memory, I have to reserve this memory by giving some name. Say for example, whenever you go to any countries or any hotel where you occupy a particular room, you have to book it. Similarly, if you want to store some information in a particular memory, you have to book it. So you have to book what? You have to book in your name, right? Similarly, out here you have to book the memory with some name. So a memory of variable, a variable is a name given to memory for storing some information. So this is all about the variable. So what is a variable? It is a name reserved, name of the reserved area memory where the information is stored. There are different kinds of variable: local variable, instance variable, and static variable. So the local variable is a variable which is declared inside the method, and the instance variable is a variable which is declared inside the class but outside the method, and the static variable is a variable which are declared as static variable. So it will be more convenient for you if I write down the example. Suppose there is a class called demo. Inside you have got the main program, public static void main. So public static void main is the main function inside which I have got one more information string AR. So now the outline is ready. So you have got some information. Suppose there is one more method. I repeat, suppose there is one more method. In fact, you need not this also to explain this. Suppose you have got one method. So void compute. So compute something else. Inside which you have declared a variable int x. So this variable x is declared inside the method which was inside the class. So this is an example of local variable. Now in Java you can also store, you can also declare the variable inside the class and outside the method int y. So this is an example of instance variable. So a variable which is declared inside the class but outside the method. Inside the class but outside the method. That kind of variable is known as instance variable, right? So instance variable is a variable which is declared inside the class or outside the method. So this is the method, and this variable y has been declared outside the method but inside the class. So this x y becomes inside the instance variable. Now the variable which is declared inside the method is known as a local. And the last one is a static variable. Whenever you declare any variable as static, okay, int z equals to 5 or whatever. So this is an example of static variable. So basically this static is the keyword kind of the modifier. Okay? It's just like the modifier of the static. So static is the keyword that I have appended over here with int z. Since I have told that int z, z is the static, so that's why it becomes a static variable. And this variable cannot be local. That's why I have appended static. So this is an example of different types of the variable that is available in Java. So just a recap of it. Suppose there is a class A and there is a method. Inside the method we have declared the variable in n equals to 90, which is an example of a local variable. If we declare any variable inside the class but outside the method, that is int data has been declared inside the class or outside the method, now this becomes an example of instance variable. And any variable if you declare it as a static, okay, is known as static variable. So we have given some number in all three. Very good. Next is the data type. So what is a data type? So data type in computer system is a method, ways with which you can store the data. So what are various different kinds of data that this programming Java program or Java programming language can handle? So that we are talking about. So based on this architecture, I've taken this diagram from the book. So it might be helpful. So there are different types of data that Java program can handle, Java language can handle, which is classified in this category. So in one hand it's primitive, another one is non-primitive. Primitive means which is pre-existing along with the language, and non-primitive means which you can make it with the help of the primitive data type. Like for example, array. So for example, let me give an example of CN. Suppose I have written int a. So int is a data type. Means that a can store only integer information. For example, 5, 6, etc. If you want the a to handle 10.5, that it cannot store 10.5 in a because a can, you have already told that a can store only integer. So for this is the impact of having data type. So if you want to store 10.5, possibly you have to use another kind of data type. For example, float 10.5. So this is what we do. This integer, float, long, double are an example of primitive data type. In C also, in Java. These are an example of data. Now, for making you understand the non-primitive data type or derived data type, sometimes the author also have used the word derived data type. Okay? So non-primitive data type. Suppose if I write int AR, okay, maybe of 5, and then you give some number. I'm not worried about it, but you know 1, 2, 3, 4, 5. Okay? So here you have stored, you have made an array. You have made an array, and this is different from this. AR is different from A. A can hold only one data, whereas AR can hold multiple data. So this has been made with the help of primitive data. So this is an example of non-primitive data type array. So that's why you can see over here array is one of the type of non-primitive data type. Apart from this, there is a class. Class also falls under non-primitive data type and interface. You might not know the interface, but later on in upcoming classes you will be able to know, especially in the inheritance chapter. Okay. Now, further classification of prefix, it can be numeric, for example, numbers, maybe 10, 10.5, etc. Also, there is numeric category. Non-numeric means character and boolean. So, unlike in C and C++, boolean was not famous, but it is quite famous in Java. So, along with the character, we have boolean also in the category non-numeric. In the numeric part, we have what integer, basically the whole number kind of thing, 1, 2, 3, 4, and then numeric means total, maybe 10.5, 10.6, 2, like that. And there are various versions of this integer float, right? Like for example, in case of integer, you have got int, long int, byte, etc. So float, you have got double, float, etc. So these are the classification of various data types, and I have already told you what is the importance of data type in terms of storing the information of the data. So if you see the table, again I have taken this from the book, this slide book. So I have not listed all, but common things I have listed out. So you can see integer falls under the numeric part, floating point falls under the numeric of floating point, and the boolean falls under the non-numeric part, and character falls under. So the very important thing that you need to know down is that whenever you create, whenever you declare any memory, or whenever you reserve any memory by declaring A, in B, etc., then what is the size of it? So here you will see integer takes 4 bytes. Integer takes 4 bytes. Unlike in C and C++, although which is machine dependent, most commonly you will see integer at 2 bytes. So far you have studied, till now you have studied integer at 2 bytes, but now it's 4 bytes. So integer takes 4 bytes. Short integer, obviously, half of it, that is 2 bytes. Long integer is 8 bytes. So the addition to the short, int and long, which you have already studied, there is one more that is not common to, that was not there with the C and C++, was byte. So byte is also a data type. For example, if you write byte A, then it is true. Possible. So if you write byte A equals to 1, true. So what is the size of this kind of data type? It's 1. Now, coming to the point, floating point, it's float and double with 4 and s respectively, not changed, unlike in C++. Boolean, it's a 1 bit, it stores either value true or false, and the character is 2 bytes, not 1 byte. So the character takes 2 bytes. So this is all about the size of the various commonly used data types. Now, let us talk about the type conversion. So far what we have discussed was the what is a variable and different types of the variable. Then we have discussed data types and different classification of data types along with the size of it. Now we will be talking about type promotion. Type promotion. So say for example, there are various examples that I will cover. First of all, I will start with first example. So suppose I have a class called data. And inside the class, I have got the main class, public, static, void, string. So my outline is ready. So initially I will write public static void so that you also become convenient with what is meaning of this. Later on in upcoming classes I will be using the word ESV. So say for example you have got the you declared a reserve on memory the A with some value 10, right? So you have reserved some value memory with some value that is 10. Now this A is an example of local instance or study variable that you should be writing it by now. Since it is inside the particular method, this is also one of the method. This also is one of the method. So basically it is a local variable. Suppose you have declared one variable in A, inside which you have stored the value. You have declared one more value variable that is of type or data type float f equals to, and inside the f we have stored A. So basically here what you are trying to do, you are storing some integer kind of information in floating point. So if you display it, system dot out dot println, if you display A, and again if you display if you display A and F, you will get output of this statement as 10, and you will get output of this statement as 10.0. So here 10 has now become 10.0. So this process of type promotion is known as a widening process, because you know that integer takes 4 bytes and float takes 4 bytes. So you will think that okay, there is no difference in byte. Then if I convert to or double, then it happens. So now the amount of bit required for storing A will be 4 bytes, and amount of bit required for storing F same information will be 8 bytes. So there is a difference. So this process is known as a widening process. So that's what I am talking about. So there is a variable in A, there is a float A, it is very this inside is a variable. So if you display it, so you get output as 10 and 10. So this process of conversion is known as a widening operation. So Java has the very good feature like Java automatic type conversion. So for widening, it's not a problem. For widening, so if the small container can be accommodated in larger container. So you need to remember that formula. The smaller container, the smaller sized information can be stored in large size container. So basically, if you see, so byte can be stored in integer. Okay, byte in integer can be stored assigned in float. Byte in integer and float can be assigned in double. So the destination size should be larger than the source. Source is this A and destination is F. So destination should be larger than source in terms of size. So this is known as a Java automatic type conversion. So you can perform automatic type conversion from one data type to another data type with some restriction. So restriction is you should use the formula or the rule. So this is not widening operation. Now another the opposite of widening is narrowing. So for that, let me declare a value. Float A equals to 10.5. So I declare a value, a variable with some value 10.5. Right? But now there is an int A, integer A, wherein integer F, wherein you want to store the value of. So is it possible? No. The answer is no. So you will get an upper timer basically. You need to run basically to understand it. So you will get somehow the other you will get an error. So narrowing, you have to specifically specify in which format you want to store the given data from source to destination. So I want to store this A in integer format. For example, I'll take help of this structure directly. So there is a float 10.5f particular number. If you try to store this f in A, then it will generate an error. So if you want to store this A in some other form, then what you can do out here is that, so A is of type float, okay, and then say for example Z. So Z is of type integer. So if you want to store a float information in integer, you need to forcefully or manually explicitly typecast it. So you are typecasting A into integer and then float. So with this, what will be the output? If you display A and if you display Z, what will be the output? So output will be 10.5 and 8. That's what 10.5. Note that float and double can be casted to any type except boolean. Means that you can typecast the float to a byte, you can typecast the float to integer, you can typecast the float to long int, etc. Similarly follows with the double, but except you cannot do the same thing with the boolean because boolean is different. It is a kind of the true or false. You cannot even do with the character also. Now coming to the point adding rows. Suppose there is a program, okay, and this is the outline. Suppose there is a program, outline of the program, and you have taken a byte data, byte A, with some value. Say for example, byte A equals to 1. Another data type we have declared of same type, byte B equals to 6. And third you have declared byte C, wherein you have stored the value of A plus B. And then you try to display system out suppose you try to display the value of C. So basically this statement, when you compile it, this statement will generate an error. Because whenever you add 2 byte data, whenever you add 2 variables which is of type data type byte, then this addition operation of byte data will result in integer. So this will give you a return of integer information, and that integer information you are trying to store it in the byte, that is C is of type byte. So basically you are trying to store integer information by byte information. So you obviously you have seen that the size of the byte is 1 byte and the size of the integer is 4 byte. So your source size is much better than the destination. So it will generate an error, which I have already discussed. So in order to do it, okay, in order to make it work, this program, what you need to do, in order to remove the error, you need to typecast it into byte. Or another way what you can do is that you have to declare int C equals to A plus B. Both will work. Okay. So this you need to take care. That's what is shown over here. You can see over here there are 2 memory variables A and B contained in this. You have added up and assigned to C where C is of type byte. So it will generate a compile error because A plus B is going to be an integer. So this addition operation will result in integer data which you are trying to assign in C which is of type byte, which is not possible. So you have to basically typecast manually. So that is the problem and solution. So finally the rules is all byte and short value. Byte means we are talking about data type. All byte data type and short data type values are promoted to integer when they perform actions, maybe addition of actions. If one of the operand is long, then whole expression is promoted to long. Example. Suppose this is long. One of the operand is long. If one of the operand is long, say for instance C equals to A plus B. Okay. And not worried about the data type. See, when you perform A plus B, so here one of the operand is long, so the result of this will be long. So that will be 50. Next is, if one of the operand is float except double, then the expression will become converted to float. So instead of this, suppose we have got float. Float B equals to 6.5. So what is the result? What kind of data types is A plus will have? A plus will have a floating data type, because one of the operand out here is that out here is floating. So B is operand, A is also operand, A is byte and B is float. So one of the operand B is float, so the result will be float. If one of the operand is double, then the result will be double. That's very obvious. So that's all for today. Thank you so much. I hope I made clear about what is the meaning of the data type and different types of the what is the meaning of the variable, different types of the variable, and data type, different types of data type, and some of the examples of widening and narrowing for type promotion or type systems. Thank you.